Today's video starts on page 15 with a problem of the day that has some review of two multiply equations. Remember, goal, inverse, balance, check. If you're not going to do the full check, at least check it with a calculator. Always, always check your work. Most important step. So please complete these 4 problems and we will go over them in class. Next page, two-step equations. Okay, they're called two-step equations because there are 2 operations. We're going to be doing the inverse of 2 operations. And equation solving is like working backwards technique. So you work through the order of operations backwards. You look for adding and subtracting first. Then you look for multiplying and dividing, and you undo those. Then you look for exponents or roots and undo those. Oops, 3, can't count. And then you look for the grouping symbols and do those last. So I call them grouping symbols, remember, because you also have hard brackets, the fraction line, and the absolute value symbol. So you're going to work the order of operations in the inverse order. Inverse is a huge concept in mathematics. To solve just simple two-step equations, you're always going to add or subtract first and then multiply or divide. So here we go. Here's an example worked out for you. 3 times n minus 5 equals 16. So it's a multiply-subtract equation. The opposite would be to add and then divide, as you can see here. So adding 5 to both sides. So here's my n, goal. Inverse of the first operation, add 5 to both sides. Cancels on the left. Bring down what you have. You don't just have n equals. You have 3n equals. And it equals 21. Now you do the opposite of multiply, which is divide. Cancel those 3's. And you get n equals 7. Check. Most important step. Rewrite the original equation. 3n minus 5 equals 16. Replace the n. 3 times 7. I think that's 21. Yeah. And you get 21 minus 5. Is that 16? Yes, that's 16. Yippee! I usually put the check mark down there. You can see it's put up here. Doesn't matter. Get the check mark on there. I did it. Fabulous. Got the right answer. 2t, 2 times t, plus 7 equals negative 1. So I have multiplying and adding. I'm going to undo that adding first. So this page is about multiplying and either adding or subtracting. The next page is about dividing and adding or subtracting. So we'll get to that in a second. So I'm going to subtract 7, undo the addition or subtraction first. Very light cancel over the top of that because negative 7 and positive 7 create 0. What do I have on the left? I have 2 t's. And on the right, negative 1 and negative 7, same signs, add and keep. I'm going to get negative 8. Now I have 2 times what equals negative 8, so it's a multiply. Its opposite is divide, little fraction line. So see here, I had a big, long subtraction line. Now I have just a little fraction symbol. That means divide. That line does not go all the way across. This is the symbol division. This represents division. It's a tiny line. Cancel those 2's. 2 2's, 2 halves makes a whole 1. So I have 1t, which is what I want. T wants to be by himself. Negative 8 divided by 2 is negative 4. So I think the answer is negative 4. Let me check. 2t plus 7 equals negative 1. I think t is negative 4. So I'm replacing it. 2 times negative 4, that's negative 8. Now I can write that. I can show this computation. Oh, negative 8, and do it one little step at a time. Negative 8 plus 7. Does that equal negative 1? Different sign, subtract. So 8 take away 7 is 1. Take the sign of the larger number. Negative 1 equals negative 1. Yippee. Now this, I'm going to circle this step. This step I could have done in my head. I could have said 2 times -4, that's -8 plus 7. -8 plus 7. Different sign, subtract. Take the sign of the larger number and jumped right down to this line in my check. I didn't have to show -8 plus 7. If you like to show every single step to be sure, please do that. You can put that line in. That line is optional. But you do have to have -1 equals -1. Yippee! Next equation. -3 times n minus 7 equals 23. Okay, it's a multiply and subtract. So the opposite, the inverse operation, is to add and then divide. So I'm going to add 7, balance, add 7 to both sides, cancel step. And I get -3n, don't forget that negative, equals 30. I'm going to divide by -3, divide by -3. These cancel. -3 over -3 is 1n. N. Yay! N wants to be all by himself. We're solving it. 30 divided by -3. 1 negative in my quotient means that my answer is going to be -10. Okay, let's check it. -3n minus 7 equals 23. Got to make sure we didn't make an integer mistake. -3 times -10 minus 7 equals 23. Now again, I could do this in my head. -3 times -10, that's positive 30. Positive 30 take away 7, hey, that's 23. Now I could show positive 3 take away 7 is 23, and then 23 equals 23. I was doing it in my head. I don't have to show this line. Don't have to. If you have it on there, don't circle it. I'm just pointing it out. You do not have to show 30 minus 7. You could do it in your head. -3 times -10 is 30. 30 take away 7 is, and go right down to here. 23 equals 23. Yippee! Right answer. Wow! Voila! I got it right. Whatever you want to call your little check mark, call it something so you remember to put it on the paper. Go to the next page. Here's our divide page. First operation that I see here is d divided by 3 plus 2 equals -8. So some number divided by 3. I'm not going to undo that division first. I'm always going to undo adding or subtracting. Remember that germ DOS in reverse? Doing that in reverse. So I'm always looking for adding or subtracting first. So, yeah, it's got an adding. The opposite is to subtract 2. Go ahead and do that. -8, take away -2 is -10. Bring down d divided by 3. Oh, okay, so I gotta multiply by 3. Up, 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 and you could put parentheses, or you could put a dot, but you can't put the x. Times 3, and some people like to put it over 1 because it's a fraction next to a fraction. You can do that. Numerator cancels denominator. Yay! D's all by himself. -10 times 3 is -30. Check. And you can see they did the check process. Yes, -30 was the correct answer. Y divided by -10 plus 7 equals 3. Okay, so I'm going to add or subtract first. I'm going to subtract 7 for both sides. There's my y, goal. Here's my inverse, -7. Here's my balance. I'm going to subtract 7 from both sides. Cancel. And I get y divided by -10 equals 3 take away 7. That's -4. Now I'm going to inverse again and balance again. So you can see we have inverse twice and balancing twice because there are 2 operations, hence 2-step equations. So I'm going to multiply up, 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 up by -10. Not down here. I'm not multiplying denominator by -10. I'm multiplying numerator. Do not want to see it down there, folks. Don't do that. Multiply up, 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 up. -10. My numerator cancels with the denominator, right? When you're multiplying fractions, numerator and denominator can cross cancel. So I get y over 1. Well, that's just y. Yay! Y's all by himself. Make sure you multiply by -10. Do the balance. Do it on the other side of the equation. So -4 times -10 is positive 40. Don't have to put that positive, but sometimes I like to. Okay, let's check this. Y divided by negative 10 plus 7, does it equal 3? Okay, I think it's positive 40 divided by negative 10 plus 7, does it equal 3? Well, 40 divided by negative 10, that's negative 4. Plus 7, well, 7 take away 4, that's 3. 3 equals 3. Notice I didn't show that computation step here. I don't have to, but I could have. Could have snuck in a negative 4 plus 7 equals 3 here. Didn't have to show that. Didn't have to show that if I didn't want to. But I do have to show the rewriting the equation, plugging in what I believe is the answer, 40. And 3 equals 3, yippee. All those parts do have to be there. Very picky process. 2/9 of h minus 5 equals negative 14. So I'm going to add first 5. So balancing, doing the inverse, adding 5, balancing on either side of the equal sign. I'm going to cancel my 5s, and I got 2/9 of h equals negative 14. Well, multiplying by 2/9 inverse is to divide by 2/9. Well, no. We do not divide by rational numbers. We multiply by the multiplicative inverse. So I'm going to balance and multiply by the multiplicative inverse 9/2 on both sides of the equation. This is my second inverse and second balanced step. My 9's cancel, my 2's cancel, and I get h equals, I did not write the right answer there. Thank goodness I caught that. Negative 14 plus 5 is negative 9, silly. Negative 9 times 9/2 is negative 81/2. Can't leave it like that, right? That's improper. So that equals negative 40 1/2. However, when I go to check this, I'm going to put it in as negative 81/2 because we don't multiply mixed numbers. We make them into improper fractions. And negative 81/2 is the improper fraction. So 2/9 h, rewriting the original equation, just like it looks. Going to replace my h, 2/9. It times negative 81/2 minus 5, does that equal negative 14? Well, 9 can go into that 81, which is why I'm putting the improper in. And I have, the 2's can cancel. And I have negative 9 minus 5. Don't have to show this line in my check. Negative 9 minus 5 more, same signs, add and keep. Negative 14 does equal negative 14. Yippee! Right answer. And that's it for today's video. We're going to practice this in class tomorrow.